Merhabalar herkese. Öncelikle etkinlikte yanımızda olduğunuz için ve katılımlarınız için herkese teşekkür ederiz. Bugün Development Workflow for AUTOSAR Classic etkinliğimizi gerçekleştireceğiz hep birlikte. Yaklaşık 1,5 saat sürecek etkinliğimiz. Etkinlik boyunca mikrofonlarınızın ve kameralarınızın kapalı olmasını rica ederiz. Sorularınız olması durumunda chat kısmında bizlere yazabilirsiniz. Umarım faydalı ve güzel bir etkinlik olacak. Hello, Tony. I guess your microphone is closed.
Yes, I will mute. Is that my time to speak, or you have something else to say? Or
yes, you can introduce yourself and
good.
That's the presentation. Thank you.
So yeah, sorry, my Turkish is really poor, so I had no idea what you said. Hi, so welcome today for the presentation on AUTOSAR. My name is Tony Petitot, Tony. Actually, I've been in MathWorks for about 2 years now. I'm specialized into code generation and AUTOSAR at MathWorks. Before that, I was a software tester, a software developer in automotive industry for many years in different companies. So I can see from the chat, and we do have quite a few people on the bottom of the V model as unit tester or unit developer. So I was more or less in this area as well in my career before that. So I will start sharing my screen. I'll switch on the camera now, and we can start. If you have any question or something is really not clear during the presentation, feel free to interrupt or to ask. If the discussion gets a bit too long, then we're just gonna stop with the discussion, and we can do that at the end if we have a bit of time. If not, feel free to reach us after the presentation, and I'll do my best to answer any question you may have after the presentation. Same thing, if I tend to speak a little bit too fast or so, just let me know and I can slow down, of course. So let me share my screen and we start with the presentation. You can all see my screen, yes?
Yes, you can see.
All right. Good. So as I said, so welcome for the presentation today when we're going to talk about mainly AUTOSAR Classic. There is a little bit about AUTOSAR Adaptive, but just as a very high level presentation. So, so it's not forgotten. So that's the agenda for today. So I'm not going through each one of them one by one. We just start with introduction. For the other part, we're going to go them through the presentation. So I understand that quite a few of you already using model-based, probably a tool. Just even if you are aware, I'd just like to explain a little bit how the different licenses work. So everything is based on MATLAB Coder for the license, so from which you can get C code, a code from MATLAB script or M file for those who are familiar with the extension. If you start working with Simulink, you do have this Simulink coder here, which is built on MATLAB Coder and allows you to generate code from Simulink model. You do have some options to configure your code, but not necessarily so extended. But if you really have like an embedded system and memory allocation is a concern because you're on the because of your processor, you're not running, for instance, on the Windows environment, or you do need your code to follow some standards, some MISRA and so on, then embedded coder is your solution, or this is your choice. And again, embedded coder will be based on Simulink coder and MATLAB coder. So that's it for the licenses. And AUTOSAR coder is based on embedded coder, so you will need one and another for running AUTOSAR with Simulink. So here, nothing too complicated. AUTOSAR has been running for many years, as some of you already know. It's an open and standardized architecture used in automotive. And in here is just a few success stories of some of our customers using a tool within an AUTOSAR environment to develop the application. So here is Fiat Chrysler developing a model-based design application using AUTOSAR to author and develop their model. We have BMW, who did a software again with model-based software using AUTOSAR. And I'm not going through one by one. Those are other examples. At the end of the presentation, later we can provide the presentation. Those I hyperlink. And if you're interested, you can still read the various articles to see how they implement the tools for the application. Oh, and there's another one. So now we're going to start diving a bit more into the subject. So as I said, AUTOSAR is a standard used in automotive, which stands for Automotive Open System Architecture. So we understand that is something we are going to use at the architecture level. I've seen in the chat that quite a few of you used terms on SV3, 4, and so on. So a SPICE term. So we will be, of course, around SV2 architecture level. It was founded in 2003, just a bit of history, by some core companies, mainly in Germany. I think there is PSA, Peugeot, Citroën on the top of it. Not sure about Ford, but some of few companies around the world, plus a big core of German manufacturer. And it was introduced as providing a standard for application to talk to each other, something standardized when systems starting to be more and more complex with more controller within a vehicle. So the image at the bottom shows the architecture difference between a non-AUTOSAR, which is when you have a software which is completely enclosed with the hardware. So something which is very hardware specific, and those two are closely linked. Then you're going to have a classic AUTOSAR when you have an application software which is talking to basic software through an RTE layer. Let's call that a communication layer which allow both of them to interface with each other. So interface layer. And on the right hand side, we have adaptive AUTOSAR layer, which is a bit similar to what we've seen in classic AUTOSAR, but mainly based on services, small standalone application talking to each other, something a bit more flexible. As the name say, a bit more services which can adapt to the environment independently from each other. And just to introduce, you may ask, why do we have classic AUTOSAR and adaptive AUTOSAR? So as I mentioned, classic AUTOSAR is something which started in 2003. The environment, the automotive environment at that time was very different to what we see right now. There is autonomous driving, for instance, was not necessarily a very strong topic 20 years ago. So at that time, the requirement for the automotive industry was very different. They just wanted some application to be able to talk to each other via a common standard. So something independent about the way you are developing your software, your interface and stuff like that. You don't need now to provide all those information to another company which is developing another software, for instance, one for transmission, one for the steering systems. They will all talk the same AUTOSAR language with each other. And whatever's happening below that or downstream the interface is up to the company to do whatever they want with the software. But the amount of data which are now necessary to process the application we see right now in terms of autonomous driving, real-time information from camera and pictures analysis and so on requires an amount of data or information to be shared or to be transferred and processed, which classic AUTOSAR is not designed for. So hence the necessity to have another standard for that, which provides, we're going to see a bit later, some additional features which are necessary for those applications. So here is a standard classic AUTOSAR architecture. So we're going to have the application layer in here with your algorithm. So in here will be some Simulink models which are performing a something you designed, and all the communication between the software component and the basic software is going through an RTE layer. It's like as a virtual function bus, if you want to name it like that. And Simulink is then used by a customer for modeling the code generation of application software. So you can use also an AUTOSAR authoring tools. So let's say an architecture software. So from Vector, for instance, or from DSpace, or we can see later some tools also from MathWorks, when you are defining your architecture and from which you are going to export or import an XML file. So as the name said, it's just an XML file which follows the AUTOSAR standard, and all your architecture, interface, runnable, AUTOSAR component if you want, are defined into this file. And since and since 2019b, you can use System Composer to define your architecture. So same as an AUTOSAR authoring tools, but as a MathWorks solution, which then of course is you don't have two different vendors, and you have a bit more confidence than System Composer and Simulink are well integrated with each other, which is, if you have different suppliers for your software, it's sometimes a little bit tricky to integrate everything with each other. And lastly, with AUTOSAR block set, you can simulate some basic software, diagnostic event manager, NVM manager, function inhibit manager, which allows you before integration to bring those components into your model and to run a simulation and to have some level of confidence on the way your software is behaving before you're actually running any test or any integration test within your processor or your application. So we're talking about ASPICE according to what I've seen in the chat. I will assume that most of you, if not all of you, are completely aware with a standard V model. And in here, just going to show you that the MathWorks tools are accompanying you across the whole V model. So you can define your requirement, your model from the very beginning of your development. We're talking about an XML file which can import and export within your models. You can, of course, as you all the model-based design user are aware, you can, of course, simulate your model very early. You can start running some tests even as a developer to make sure that whatever you are developing is behaving as expected before formal testing. You can generate code from your model, as you may be aware, And you can run then the official testing phase. We've got several tools for that: Seal, Peel Manager, Simulink'te test. And then, as we mentioned in here, you can import an XML. You can start with your whole development, generate code, testing, and then you can export an XML again, which includes some of the changes you may have brought during your development, and integrate that in another tool at a higher level into your development process. So we are now going to just briefly talk about the adaptive support in Simulink, just to show you that we are supporting both standards. So, as I mentioned, why are we having a new platform? So we can see in this image, for instance, if we were interested or we are developing an application which can be used for autonomous driving, you need to be completely aware of your whole environment. They're also extremely safety critical. So you will have all those camera, sensors, radar, to be able to map your whole environment, and all of that need to go an incredible amount of data, which will need to go through your whole architecture to be processed quickly in order to react, for your application to react timely, and to ensure complete safety of the user. The car will also allow or the vehicle to be completely connected with this environment. Again, we're talking about huge amount of data, and we're talking about being connected to the outside world, which is not possible with Classic. It is something which is in the car with standard bus and is not aware of what's happening around, neither has any interest about connected to what's happening around. Talking, for instance, once again, of a steering system or a transmission, with those are fairly standard application, or your brake system, for instance, or your suspension. And of course, because you have those software which are developed quickly and need to follow the trend of technology, you need to have the capability to update your software regularly. A very similar analogy will be when when you're receiving a notification that the software of your mobile phone needs to be updated. You're not bringing your phone to the vendor to say, "Oh, update your software." You're connected to your network, you update the software, and it's done. And it will be exactly the same thing, which means that the car you buy and the software which is in there will be very different in the month to come, because you will have this constant update. At the opposite, for instance, for the standard application, you can see that when there is a software issue on transmission, on brake and stuff like that, the vendors are calling back all the cars to be serviced. That is not possible. That is adaptive AUTOSAR allows you to update the software over the air, for instance. So here, just to summarize a little bit about why we need, again, a new platform. So all of those which I have already mentioned are actually not possible with Classic. Again, we're talking about a standard which was released 20 years ago. The requirements were not the same. We're talking about standard application from car which were similar as what they did from in the 90s and the 80s. You had the transmission, you had that. You just wanted to have those applications interface with each other. Now, but within the vehicle, now we need a vehicle which is talking to this entire outside world. And same slide, but what is adaptive? Once again, over-the-air software updates, the mobile phone thingy, high data rate to support the application. So Ethernet based, not something which is CAN bus based. So again, the amount of data which can be transferred and the speed rate is much higher, and can now be processed with a standard. Service-oriented architecture, adaptive AUTOSAR is C++ based, which means that when you have a classic AUTOSAR platform, you do have a software, you have your layer of architecture, which is talking to another application. Think about, and that will be one ECU talking to another ECU. In adaptive software, it's service-based. Think about some independent little software which are talking to each other, sometimes within the same ECU, providing or requiring services, or sometimes doing both within the same ECU or some other ECU, and each one of them being fairly independent. Maybe a clumsy analogy would be the application in your phone, for instance, which can sometimes retrieve data from each other. If you're into sport and stuff like that, you may use Strava, and then you have your mobile phone health application, which is retrieving data from there, and vice versa, within your own environment, which is your mobile phone, which is also talking to this outside world, regardless of what's happening with your application. So we some of the similar image we had seen already, just as a very quick summary about the difference between computing power. So this is instruction, the data instruction process per second, the amount of data which needs to be transferred. We're talking about safety criticality. In classic AUTOSAR, you may use AUTOSAR, but it doesn't mean that everything is ASIL or has to be ASIL D. In adaptive AUTOSAR, it will be at least ASIL B rated. As I say, most of those applications are safety critical. And when you start replacing the user and having to understand the whole environment, you cannot fail. And of course, any failure in that can be quite dramatic. Sorry. And for that, you do have the possibility to use MathWorks tools, Simulink'te, to develop your whole application, regardless of from your ECU. Different coder allow you to generate code in C, C++, HDL code according to your application. The possibility to develop application following AUTOSAR Classic standard or AUTOSAR adaptive, or to follow adaptive standard. So for AUTOSAR adaptive, I will just stop here. It's just really because otherwise we will not have enough time. It's just to show you that we are supporting adaptive standard as well as classic. And something to mention, MathWorks is a key player or an active player into the adaptive standard, which means that we are also actively taking part of the redaction or the writing of those standards, which of course allow us also to integrate that into our tool. So now we're going to go a little bit deeper into the subject, and now we're going to focus solely on classic AUTOSAR. Checking the time, we have an hour left, so eventually plenty of time. So MathWorks' approach to mapping Simulink to AUTOSAR. So in here you have a sorry, an XML file which will be defining your architecture. So very typical file. The way your component will look like into your authoring tool, whether you, as I said, using System Composer or Control Desk from DSpace, DaVinci from Vector, and the Simulink model or the function model, which eventually would be a representation from what is described into the AUTOSAR, and one to each other can be completely mapped. So this textual representation or textual representation into the XML, or what you have represented into your authoring tool, can be completely mapped into Simulink, and of course developed further, modified, improved, or corrected. So in here we would have, for instance, a software component which can be mapped directly to a Simulink model. So the AUTOSAR architecture will mention about 3 runnable with 3 clocks, which we can have an exact representation into Simulink. Within each run, so in here will be an AUTOSAR word, and within each runnable, so you have your mapping, you can then inside your runnable include your whole Simulink algorithm. So some of some of you are unit developer or tester. So within your runnable, then you can bring all the application or the model you actually developed at unit level. So similarly about interfaces and how to map one to another, each port of the Simulink model, so in here the input and the output, can be completely linked to what is described in AUTOSAR. So in here we have a port which has 2 elements, so it could be a bus as well, and same thing with the output, which can be completely linked with one and another. So again, Simulink gives you an exact representation of what is described into your XML or in your authoring tool. So talking about all the various possibilities which can be used to model your software and again map your interface to Simulink. And so everything which you have or may have used within AUTOSAR, the way you are defining data, array, vector, can be done in Simulink and mapped with AUTOSAR and vice versa. So you have all the modeling capability offered by Simulink within the AUTOSAR world. So whatever complex interface is described or defined in AUTOSAR can be completely imported in Simulink or developed in Simulink and exported to AUTOSAR level. And we were to finish on the mapping subject. If you have used within Simulink a new development data dictionary, so similarly you have within an AUTOSAR model in Simulink an AUTOSAR data dictionary, from which you can, define all your interface, your runnable, whether you are you compute method, which the configuration of your AUTOSAR environment within the data dictionary. Sorry, and all the information will then be completely present into the dictionary and can be linked within the model, but everything is then centralized into one location. And so you can import these for an XML. You can also modify those, and then the new information will be part of the XML you will be exporting at the end of your development. So if we were going to an example about how everything is mapped, for instance, this is an example of the configuration of the setting you can apply to your model. So here we're having Simulink model. We have this input key. I hope it's big enough for you to see, which is defined within your data dictionary, your AUTOSAR dictionary, which is defined into this dictionary in here with the interface key. This information provided in or present in the AUTOSAR dictionary can be retrieved in the code mapping. If you are aware with the code mapping, that will allow you to set the information from the model code related into this interface. And you can, of course, choose which AUTOSAR standard you want to use for your code. And all of those are inscribed within each other as completely integrated. Kind of a closed looped system, if I want to phrase it like that. And once you have applied all those settings, you can then generate or export your code and your XML file. So let's summarize a little bit what we have talked about. Checking the time again. Okay. So port, everything which is present in the standard, so that sender receiver, client server, port, non-volatile interface can be modeled in Simulink. Behavior, we have seen a very example when it was function caller, so function call based, rate based. Simulink function can be used within the AUTOSAR, and we give you the possibility to use those to model your application. Internal data can be modeled in Simulink. All those information which are defined in AUTOSAR standard. Possibility to use variant according to some platform you may have. So you can define then different type of architecture or model according to some control platform. And all of those, as I said, can be modeled in Simulink, from which you can get then your code and your XML file. So design workflow. So talking a little bit less about the mapping, but just understand what are the different directions which are supported with our tools. So in here you have an architecture which has been modeled, whether it's in Simulink or in System Composer. What can you do from it? You can then generate your code from your C file, and you can export an XML. So in here you are developing directly your model in AUTOSAR. This is your starting point, if you want. And then you export your generating code, and you get an XML which can be imported at a higher level into your architecture, for instance. And that, of course, is called bottom-up, because the starting point is your model. You're not starting by the architecture level or the authoring tool or the XML. Now, let's assume then another company is doing the architecture, or another department, and you have an architecture department which is just providing you all the architecture information. So the authoring tool or the architecture tool, let's call it like that, will export the XML, which you can then import into Simulink or System Composer. And then whatever's described here, you can inherit within your Simulink environment. And as you can guess, that's called top-down, because the starting point is the architecture, and we are going down to the level. So talking about SPICE a bit earlier, so we are SVE2, and we're going to SVE3. And now, as you can imagine, let's say we're starting by the authoring tool, we exported in XML, and then we start making changes to your architecture, to your model, modifying the interface, adding a runnable, and now we start having a difference between one and another. And then you can, let's say, import the XML to Simulink, and then you can export the XML from Simulink, and that is called round tripping. And once you have done all that, your code, you generated your code, you exported your XML, everything is closed. You can also run or start the testing phase whether you want to do a seal test or a peel test. So software in the loop and processor in the loop for those who are not too familiar with the testing jargon. And now we're going to start doing a little demonstration. So let me just leave the presentation and I'm going to MATLAB. Good. So let's assume now you are quite new to, you never used AUTOSAR before. You just have a project which is required to follow AUTOSAR standard, but you have nevertheless loads of models which are already developed in Simulink'te, but not in AUTOSAR, which means that you have all those legacy models. So ideally speaking, what you want is to convert those into AUTOSAR. So here we're having a very small model. Something I would like to point out, at the end of the presentation, I will not show you that, but if you are requiring the presentation, it will be distributed to you. I have put some links with what I believe is interesting information, whether it's some example or some configuration settings and stuff like that. And this example can be found in this list of links at the end of the presentation. So you can find that directly from our website. And here, if I'm opening the configuration settings, so it's Control E for those who like the shortcut. It's embedded code. So the model is set to use embedded coder. If I am opening the application, for instance, embedded coder, then I have the regular code mapping for those who are familiar with it. Let me just pin that so the window doesn't disappear. And then you can see it's the same thing as normal. If I'm going to the storage class, they are the standard storage class you can find in embedded coder. But nevertheless, I want this model to be AUTOSAR. So how do I do that? If you have a model, a Simulink model, which comes out set to a standard coder, and you're opening the AUTOSAR application, you will directly be you will be directed to this AUTOSAR component quick start, which will allow you to convert this model into AUTOSAR. So we're going to use AUTOSAR Classic for this demonstration. The name of your component, whether you want to change the component type, component package, or whatever, we're going to use the default standard. Press next again. Maybe you have an XML actually, and this is what you actually want to do. You don't want to do anything with this model, but you have an XML to import, or you want to create a default setting based on this particular Simulink model. And I am selecting finish, I'm waiting a little bit. Just to mention, when someone's sharing the screen with Teams or so, it's always a little bit slower. So I'm sorry for the waiting, but it's not a big model. We shouldn't wait too long. So what do we have now? Not something which seems different. However, we have now the code mapping is now different. We have some import. The data, we're not talking about storage class now, we're talking about data access mode, whether it's implicit receive, explicit, and so on. We can see that now we are in AUTOSAR level. And if I'm going to the configuration parameter of my model, we are now in AUTOSAR. We have AUTOSAR option here, which are available with which version of AUTOSAR you want to use, and so on. Plus, of course, identical or similar code optimization setting which are available with embedded coder. And here on the left-hand side, in the corner, in the code mapping, I can now open my data dictionary, AUTOSAR dictionary, sorry. In which, if I am, let's do it like that. In which now I have, so the various interface here, which are which can be created. The port of this particular runnable. So here's my import, my output. Same thing for the sender port. All the configuration settings which I was mentioning, all that is now available, and you're ready to start working on with this model in AUTOSAR. And if I was going to generate code from it, so Control B, or I can generate code from here, but once again, I like shortcuts. It's working, so it shouldn't be too long. And every time I have a sip of tea. So a little bit of patience. We can open this diagnostic window and see what's happening. So starting building. Take a bit of time, so I'm sorry for that. Kind of a funny story. If you guys know Jeopardy, I have the music often on my mind when I'm generating code for any reason. So now we're generating the XML file description. So technically the XML file. So it shouldn't be too long, which means then now we could generate standard code before we are now in AUTOSAR level. And we are going to generate AUTOSAR compliant code as well as, so let me close that. So here we have our code. And we can see then the code anyway, start not talking now about some RT, so runnable port or interface with RT. So now we have generated a complete AUTOSAR compliant code, and you can see the list of the files which are generated. We have your RT type, which is defined here, all the XML of your model here. So with the component, the different port, so all your interface are here present into an XML, which can then be imported within an authoring tool, as we already mentioned. So let me just stop that for this demonstration. We have a couple more later. So let me just go back to the presentation. And sorry. So, and here, as we mentioned earlier with a different process, we've done a bottom-up approach. So we have a model, and then we're generating in our XML and the code. So function call modeling style. So let's assume now we have this AUTOSAR representation, whether you developed it with System Composer or else another tool than you are using, your architecture. You would like to have this exact representation in Simulink. So once again, we have that little guy, and what we want is to import. So from this authoring tool, we will have an XML available, and we'd like to import that into Simulink. How do we do that? So it's actually fairly straightforward. We just have these two lines of code. So that's the name of the XML, which will allow you to import an XML. So once again, even if you have not used AUTOSAR and you have an XML available, maybe from another vendor, another company which will be working on your architecture department, with this line of code, you can import it and you will have this exact representation into Simulink. So you can see the layout is similar, the interface are identical, and so on. Now, let's assume the architecture department is giving you an XML file, and then a couple of weeks later, whatever, they brought some modification into the architecture. You would like to import this new XML, but doesn't mean you're going to start from scratch. And what did they change, and so on and so on. It's actually possible, again, with the XML importer in Simulink to update your architecture from a new XML. How do we do that? Once again, a couple of codes. So the first one is identical, it's an XML importer, but this one we're going to specify that we want to update the model from the existing one. And what do we get? So if you remember, we had this, so the green guy in here was just not there, the red one was present, and we're importing we updating architecture with a new XML file. And we are shown the changes in your model. So we have this new runnable in here with the new interface. And here we have another interface. Of course, you cannot model what has disappeared, but there is a report which is also generated, which will list all the parts which have been removed. That is an HTML file. It can be changed, it can be opened separately. And then you can see exactly where are the changes without, and not necessarily start from scratch. So much easier for model review. And once again, we're going to go back to a demonstration. If you have any question, just let me know. You can ask. So let me just close the previous application. No, I don't want to save. I'm going to clean that, and I'm going to another example. And this one will be function call. But yes, hello.
Hello, this is Mustafa. Do you have an example for basic software site that also, I suppose, that you showed to application site?
Yes, I have. So two things. I'm gonna show you so in a third demonstration, we're gonna have basic software module into a demonstration.
Okay, thank you.
I'm not sure I will have the time to show. I have prepared a model which is a simulation of a diagnostic event manager, which are finding a fault and reacting to that. If I don't have the time to show this example, I have nevertheless at the end of the presentation a link specifically with that example when you can simulate an application of basic software and how to visualize or observe how the model is reacting to it.
Thank you.
You're welcome. So I have opened a project, and we'll just open this AUTOSAR composition model. Sorry, as I said, everything takes a bit more time when you are sharing. So nothing too fancy. In here we have some input in order, some feedback in order to validate, control, prove, check our composition in here. So I will just start by running first a simulation, and then we're going to dive into it and I'll show you a little bit how it looks. So in here we're not in AUTOSAR, it's just a regular embedded coder and stuff like that. It's just for the simulation purposes. The AUTOSAR part is this model reference in which we are going to go. Are we going in a second? And I have run the simulation and I have that. It's not that important. Let me do a screenshot of that because I would like later to show you something. So we save this guy for later. So I can run a simulation and whether and then assess if my model is behaving as expected. And now I'm going to this composition model. When I have, so the layout is very similar to what we showed a little bit earlier. And here I have function called model reference, and so each of them being a runnable, and I have inside my algorithm. So here it's nothing too fancy, it's just a lookup table, and each of them will have its own algorithm. So I'm opening my application, and once again, if I'm going back to the function interface, I have my little import, data access mode, and I have my data dictionary. In here, just to show a bit about the difference and we saw in the previous example, we have this throttle position sensor, which is this component. And very similarly, we have the interface, okay, this percent, this hardware input interface. But in here, we can see I have many more software server receive interface. And that's all of the interface present in the composition. And here, it's specifically for that component. If I was opening another component, I will have then all those information here present. But just for another, but the mapping would be specifically here presented or shown for that particular component. So once again, we have then something very similar. We have Simulink, we have the AUTOSAR data dictionary, our interface I define here, and so on and so on. But now, let's say we don't have that, and the only thing, oops, sorry, going back to here. The only thing we have then is a blank model reference, and we're starting from scratch. So how do we do that? So let me just close all those guys, have something a bit clean. So we mentioned then to import an XML. So I have my XML here. Come on, ready. So okay, no, let's see if I'm opening the right one. Yeah. So typical XML when I have everything defined, and that's it. So I'm not going into detail, just to show you, okay, this is my XML. And I mentioned earlier that with a couple of lines, you can just import the XML. So I want to show you, I didn't lie. So I only have these two lines, XML importer and create composition as model. The composition is this model when all the runnable are linked or connected with each other. So I'm just going to run this script, and we're going to wait a little bit for the import to be finished. So NSAD is creating. I have one component. So I know I will have 5 components. Created model. So component 4, component 5. Name being similar. That's why it's complaining. And now I have this composition. But what's the difference? I have the same runnable. So let me just open the runnable itself. So similar, I am still in AUTOSAR. I have a component, I have my data dictionary, but if I am going inside, I don't have any algorithm, because AUTOSAR at the end, it's an interface standard. So now I am ready to receive my algorithm. So as I mentioned a few times, some of you are unit developer or you are at that level. This is where you're going to start. You get the XML from the architecture guys. You're importing it, and now you can drop all your algorithm within the AUTOSAR framework. And just to show you very quickly, just for the demonstration, if I am, so going back, where's my script? Here, mentioning that if you want to update, it's also just a couple of lines. So XML importer is identical. Here we want to create composition model. And then the function is a bit different. I want to update the model, which is, of course, the same name. And I will run that. Okay, it's 2 o'clock. And now it's going to start. So we're going to start opening. Now it's talking about 6 components. Okay, so update. So on one is updating component 1, component 2. So on updating. Saving the model. And I have a report, as I mentioned earlier, which is pointing to the changes into the model. And as shown in the slide, all my changes are now highlighted in green. And from the report, so let me just do that like that, I can now in selecting navigate with the selecting the hyperlink or clicking the hyperlinks, navigate to the exact location of the changes into my architecture. Of course, the deleted are not shown, but they are listed into the report. And it's telling me that this component TPS secondary, which was here, has now been deleted, as well as all his interface. And that is that's it for the demonstration. We can see how quickly we can import or update on our XML and start dropping the 1, 2, 3, the algorithm or the unit within your composition. So let me go back to the presentation itself, to that. And oh yeah, something to mention, there is I have put actually one of the links I put at the end of the presentation is the release note, because I don't know what version you are using. I don't know what version you're planning to use in the future, but you will see the list of new feature or improvement which are included for every single release. So as just no, it could be a presentation on its own to detail for each release what we're having, but something which can be interesting is something which some customer asked for us quite a bit of time, is the possibility to generate an A2L file from an AUTOSAR model, and from 22A it is now possible. So if any of you, we're talking about some of you guys are software tester, and I'm not sure if you are doing also some calibration work and so on in the system, you can now export an A2L file. This is where it is located. So you have at the end this, if you are using a Manicoder and you are generating A2L file, it's very similar. You have the share button on the right hand side of your tab on the top. And that's it. So it's as shown as that. Oh, and that's the setting, sorry, of your calibration. You have different version for your A2L. Whether you want to generate also a CDF file, you have address replacement, all that is now available. Good. System Composer, we mentioned it a couple of times. And if you guys are using an authoring tool, you can now use MathWorks tools to do something similar. So where are we into this this level? We are right here. So you can now model your entire architecture. You can export XML and import that to Simulink, or as I was going to show you, you can also include your Simulink model within your authoring tool and have one another completely integrated with each other. So not spending too much time on that. It's just a navigation panel for System Composer if you are not familiar with it. At the end of the presentation, one of the links I have placed is a video, it's about 10 minutes, and it shows you how easy it is to actually create an architecture model from scratch with System Composer. Okay, so sometimes it's a bit accelerated, but you will see actually the tool is fairly intuitive. Oh, it's actually written intuitive. This is how it looks. You can create composition very similar to what we've seen, but not in Simulink, but on something which is developed for system architecture. I don't see the chat now, so I don't know if we have a few architects today, but this tool is for you. You can import XML, you can define component. And here is really an architecture tool. So you're not putting any algorithm or functionality. You are the architecture. It's really interface definition. And then you can export, you can generate, actually for System Composer, you're not generating an XML, they use export. And you can do all that. Basic software. The question, we're going to talk about that a bit more again, but this is more or less how it looks for this thing. You can have a basic software module. So whoever is dealing with that, the capability to be able to simulate the basic software into your Simulink model before the integration, it's something which was quite requested or demanded by the customer. You can create this harness model. So very similar, identical to what I have shown with Simulink. So you can validate your composition developed in System Composer with some input, test vector, and so on, and visualize the outcome of your composition. You can play with the scheduling of your composition. So really something which is optimized for architecture. And what do you get from it? Exporting like folder which will contain either your UI XML files with each of your components, your interface, data type, and so on, as well as all the C files or all the code which is generated from that particular composition. And demonstration again, we need to rush it a bit. We have 25 minutes left. Pressure. So let me close all that. So I need to clean it a bit. I will close my project. They're going to clean that a bit. AUTOSAR, where is the guy? System Composer. So very similar. I'll open again Simulink project. I'm not sure if you guys are using Simulink project. So you can link all the relevant document into one framework, script, requirement, and so on. You might recognize this test harness. We have seen exactly the same, and I wanted to run a simulation again. And if you remember, I've made a screenshot during the previous simulation, and I would like to show you something. So again, a bit of patience. And if you're like me, you have Jeopardy in your head. So take a bit of time, so I'm sorry for that. So in the meantime, if you guys have a question, just please unmute yourself and you can ask. If not, then we'll wait. So once again, I am sorry for the waiting. In here, this little button in there, which you can see you have not seen above the composition, is the scheduling editor. You can see also that System Composer is working with buses. We have a bit less interfaces, and it's actually really buses based architecture level, really. So, and if I am opening my scope, come on, if you want to open. Sorry, I'm trying to open the scope. If you will be kind enough to open, that would be lovely. Unless I have, oh, okay, it was undock. So that's my scope. And if I am going back to the screenshot earlier, you can see then is the scale is a bit different. The scale is exactly the same. So let me stretch a bit. You have exactly the same behavior. What I want to show that is regardless of which tool you are using, whether it is, and we're going in now. Come on. I'm opening the model. Whether we are using now System Composer or Simulink, the behavior is exactly the same. So just wanted to show you it doesn't change really which tools you are using. You will have a similar, identical behavior. For the question about basic software. So for instance, in here, the way it's, so here is my lookup table I have shown earlier, but I have now some basic software module when I am recording or detecting any failure, any error into my software according to the behavior of the software linked to the basic software. There's a lot of software in my sentence, I'm sorry. So here I have some NVM service caller, have some set point set and to the initialization. Those are read here. I'm setting some status according to some requirement. Those status will be all read in here, and according to some condition of those status, I'm gonna react accordingly. So in here for the question, for instance, if I am detecting an error in one of those, I will switch from the primary sensor to the secondary sensor because I have detected a failure. And if I have two errors in there, which are detected, which means that, for instance, my two sensors are faulty, then I will react completely on it. So this is the status of my sensor. So it's not TPS sensor 1 and 2, is status of my sensor, and that will affect directly the whole output of my entire composition, which is at the end this guy. Did I answer the question about the basic software? There was Mustafa, I think, if I remember the name.
Thank you, Tony.
No worries. So again, so this is all my. Yes, please, please.
Tony.
Go ahead.
That's, as I saw the MVM part of also diagnostic event manager side, all that functionality is coming from in Simulink side in AUTOSAR block as a built-in function.
It's a part of AUTOSAR block set, and here we are in System Composer. But if you select the link I put at the end of the presentation when you're going to receive it, you will see that the example is with Simulink. So those two can be brought. Actually, you know what? We're going to open quickly the library browser, and you can see there is this AUTOSAR block set in there. And oh God, everything is long when you share. And if I'm looking for AUTOSAR block set, classic platform, I have the basic software here. You can see. So it is part of AUTOSAR block set, and it will be, you can use them whether you use System Composer for AUTOSAR or Simulink. And the example I put at the end is how to simulate and how to use that, which is exactly what I've shown actually.
I was thinking, sorry, Tony, I was thinking about that all that basic software part is coming from AUTOSAR block set. But as far as I saw from your block set sites, that, for example, I couldn't see CAN driver part of basic software and lean and etc.
Oh, it doesn't mean, so at the moment, some of the, which is defined in AUTOSAR standard, we have implemented some part of it. I'm not telling you that everything which is in AUTOSAR standard is currently available. So it's a work in progress, if you want. Yeah. So slowly, I'm expecting they will implement more capability, but I will not tell you at the moment everything is possible. Actually, I will show you, for instance, for sub routine AUTOSAR routine, we have starting implementing some capability, but not everything which is in AUTOSAR is available currently in Simulink.
Okay, thank you, Tony.
Good. So we're running a little bit out of time, so I will stop for the presentation in here. We just want to show you something very quickly, which I will. Oh, come on. I will not go into detail. I just want to say that again, if you're starting from scratch and you have a blank model, you can then in here import from, so in the modeling tab, you can select your XML, and then you will be importing your XML into System Composer, and you will have something identical to, oops, sorry, come on. And you will have these compositions similarly to what we've seen in Simulink. Because of time purposes, I will just skip that. But bear in mind that if you have a blank model, you can import directly the XML. It will take a bit of time, and I would like to skip this part if that's okay with you. So let's continue with the presentation. So I might rush a little bit. So we're talking about basic software capability. So as you can imagine, for those who are working with it, there is many calls between application software and basic software. Basic software is fairly dynamic. We're talking about the reaction, and simulation of basic software will increase the confidence you have during the development before finding any error during the integration. You can also check that your software will react accordingly. We're talking about basic software library. Mustafa, to go back to your question. So we have, so for instance, this is for diagnostic event manager. Specification is 475 pages, which we included into what I have shown you earlier with some capability to be able to simulate those. Sorry. AUTOSAR library routines. So there was something which were asked by some of the customer to be able to simulate and generate code from these AUTOSAR library routines. So those 5 blocks, for instance, so this was an interpretation. If you go to what is in AUTOSAR, you will have many more. I would expect that in the future, we will have more routine available into Simulink, but just to give you an idea, those 5 blocks are covering 127 routines defined in AUTOSAR standard. So eventually it does make your life a little bit easier. And just to show you an example, this is how your code will look like. And oops, and here there will be a very small video. It will be part of the presentation, so you can simulate that later as well, because I have a problem with my my bar. You have some detection about whether for the seatbelt according to some control, and in here will be what is observed or recorded for the basic software. And so we have something which is detected, speed stuck low. I'm going to click on that. The control is going to increase the speed. And now we can see that past a certain threshold, we have detected a failure in here. Get fail status is now going from 0 to 1. So just to show you that you can set an entire simulation and you can, oh, good Lord, have something not nicely set for your visualization with a nice user interface. Testing. We have a few testers in here, so that is your part. Sorry for the throat. So Polyspace, I don't know if you guys are familiar with Polyspace. We have mainly 2 main products, Polyspace Bug Finder and Polyspace Code Prover, which will allow you to run some different check from one tool to another on your generated code. So Polyspace Bug Finder, it's the tool which can be used quickly by some developer. They're going to check the code. Is the MISRA compliant? You're going to have some warning. You can change your model. You can use that on a day-to-day basis, and which ensure that whatever the developer is doing is going to be nice and clean and not going to be flagged later by the tester guy and saying, I have too many warning. We need to change the model. Because as you're all aware, everything which is fine by the tester increased the development time quite drastically. because then you need to re-go through the V model and to go through the loop again and again. So everything which is done earlier, it's time and money saved for the project. So fast, easy, precise. Once again, this is the tool for the engineers, the integrator to check the code. Polyspace Code Prover is an extension to prove the absence of runtime error with something which is more formal, more complex, a bit longer to run, and which is mathematically based to really give you the, well, not the bulletproof because it doesn't exist in software, but really more confidence and more check on your code and whatever you have developed. So if we were going through a workflow using Polyspace, it will look something a bit like that. So you have your XML file, you have your C file, your header file. You're importing them to Polyspace for checking. Each module contained, so we have the C file, and then we're gonna, the analysis will check how the runnable are implemented, the data type specification into the XML, what you have in, developed a model with your C file. It is could follow the, so technically they're going to check the C file according to the XML file. It didn't have any mismatch, any error. Runtime error will be will be checked for to prove the absence of it. Overflow could be one of them. So now we're not talking about something which is really about data type in quick implementation. We're talking about really something which can create surprises. You all developer, I'm sure you had some overflow issue. I had a few when I was a developer. It was never funny. And then you will have a report, which is going to follow the color code on the Polyspace, you know, so it's green when it's okay, it's orange when you have a warning, it's red, okay, red is always bad, and so on and so on. So to check and to prove the absence of error. Since you are, once again, some of you guys were putting into their responsibility or their job where they are standing into the V model in ASPICE. So you I suppose or assume you all have to work with the ISO 26262. One part of the ISO is the necessity to qualify your tools for being compliant with the standard. And there is a tool from MathWorks which allow you to use some test suite, so some pre-ready check, which gonna help you to qualify your tool for a regard to ISO 26262. So what does it mean in principle? Why do you need to do that? Because you might think, oh yeah, but the tool, okay, is compliant. The tool needs to be qualified in your environment. So it's pretty much that. We're providing a tool, you need to qualify it for whatever is your application. So, and that is what is required to the ISO. And in here, you will have all the, according to the ISO and the workflow, where are all the MathWorks tools within a complete development process, and which tool can be used for supporting your process according to a full validation and verification workflow. So we have Simulink check in here, Simulink design verifier, which can be used here. Simulink requirement, which you can use to link requirement to your code, to your model. The generated code will contain a link to this requirement to ensure full traceability and so on. Then you can check Simulink test for seal, peel, back-to-back test, mill, seal. If you are you want to do unit test, poly space again for the code check that we mentioned earlier. So key takeaway. So we're arriving at the end. We okay a bit of time. Just to summarize a little bit what we have talked today. So we mainly focus today on Classic, but as I mentioned, AUTOSAR Adaptive is fully supported. The process that I mentioned with the bottom-up, top-down, round-tripping is identical with Adaptive. The way it's defined is a bit different in terms of the architecture of AUTOSAR Adaptive and Classic, but both of them are fully supported. You can simulate your composition, you can simulate your algorithm, you can include basic software module into your models. You can create your architecture in Simulink. You can author your architecture in System Composer. And as we've seen with, I might have still that open, we have in here my composition model in System Composer, and in here when I'm going inside, it's a pure Simulink models. I am not in System Composer anymore. So getting back to my presentation. We can generate C++ code for code generation. Something I haven't mentioned, you can, of course, oh no, it's not obvious. You can use code replacement for your code according to the hardware you are using. Whether for your processor, there is a possibility to generate hardware-specific code and have an optimized code for your application. We're talking about you can perform peel, seal, Simulink test, seal peel manager if you guys are using it. We're providing some tools which will allow you to qualify your workflow, your tool chain, according to ISO 26262. You will have to do it, or you're already doing it, or you have done it, but it could be quite a tedious work to do it by yourself. So in here, there is a tool which can help you for that. And to finish, we mentioned about polyspace, which can check all your generated files, which means your code and your XMLs against each other, against the AUTOSAR standard, against some runtime error, mentioning about overflow to increase the level of confidence of your application, and at the end have a better product. So that's it. And just quickly for the next one, there's some of the link I was saying, then you can get at the end. So basic software simulation, System Composer, the quick start we're mentioning when you got a Simulink model and you just want to convert it to AUTOSAR without really knowing how to do that. Some of the AUTOSAR configuration, how to configure a Simulink model according to AUTOSAR. And here, as I mentioned, the release note, when you can really see how much is implemented at each release. I'm not sure how we're doing with times. It's almost done, but have you guys any questions? So it's a lovely winter in Germany. Any questions? So as I mentioned before, you will receive if you want the presentation, just ask us and you can receive it. I'm not sure how that works for the distribution, but I will make sure that the presentation is available to all.